Hello. So our today's question is solve the differential equation where our equation is x sine by y by x into dy by dx plus x minus y sine y by x equals to 0. Given that our x equals to 1 when y equals to pi by 2. Coming to the next slide. Here we have dy by dx equals to, it's the same equation, we've just rearranged it to get dy by dx separately. Now using the homogeneous differential equation, we know that y equals to vx, and then differentiating on the both sides we get this, or some other form of this equation is written as dy equals to v dx plus x dv. It's the same form, we've just written it differently. Now in both of these we've got dy by dx, so we'll be equating both of these. We've just written what we had. Now if we take this v to the other side, we'll get a minus v. Going to the other slide. From here we can see that we had v sine v minus 1 upon sine v minus v. So if we take the LCM of this one, we get a v sine v here. We've crossed this and we've got our minus 1 by sine v. As we've already simplified it to the most, we'll be integrating it. So we've rearranged that dv and sine v come on the left side and dx come on one side. So integrating minus sine v dv, we get plus cos v, because integration of sine v is equal to minus sine v and minus minus become plus. And here for dx by x we get log x plus log c. Now we'll be replacing v. We took y equals to vx, right? So v equals to y by x. We just replaced our v back, and by the property of log, if log x plus log c, so we get log x into c. Now we know that we have to take x equals to 1 when y equals to pi by 2. So for that one we have cos y by x. So cos y by x equals to log pi by 2. Cos pi by 2. So here we get that our c equals to 1. So our final answer we get as cos of y by x equals to log x.